Good morning and good afternoon. This is Kristen Schloss, and I'm with Razorleaf Corporation. I'd like to welcome you to part 2 of Razorleaf's Digital Thread webinar series. This is our second webinar in the series, 3 ways to get started with a digital thread. Today, our experts will demonstrate how your organization can incorporate a traceable, connected digital thread with 3 different client examples using key steps in each use case. I'm pleased to introduce our 2 expert speakers on the digital thread. First, Jonathan Scott is our Chief Architect. He is our digital transformation evangelist, promoting the use of digital thread and digital twins concepts for over 20 years. Jonathan is a former solution architect, project manager, and technical consultant on multiple PDM, PLM, and CAD platforms. His background is in mechanical engineering in both nuclear and transportation industries. Second, we have Derek Meading, our engagement director. He has over 20 years of experience in engineering and manufacturing, including working in the regulated medical industry. Derek provides clients with their automation, integration, and digitization of processes, including best practices and methodologies. Before I hand this over to Derek, just a few housekeeping items. First, the webinar will be recorded. We will be sharing this recording to all registrants. If one of your colleagues was unable to attend, we encourage you to share this recording. Also, during the recording, we value your opinions and encourage you to participate and ask questions. To ask a question, please enter on the GoToWebinar question panel at any time. We will have a Q&A session at the conclusion of this presentation. Now, I'm going to hand this over to Derek.
Awesome. Thank you, Kristen. Thanks for having us and thanks for setting this up. We welcome everyone that's on our webinar. If you attended part 1 of this, welcome back. If you're new, thanks for taking some time. We're going to do a little bit of a review just for a few seconds, just to make sure that everybody's at the same point and we set the stage before we get into some of the details specific to this webinar. So Jonathan, I thought we'd start with going over this definition of the digital thread again, just to make sure, once again, that everybody's on the same page. And so the definition that we're going to use for the purpose of this webinar series is that the digital thread represents a set of connected records of the data and activities which define a product. So essentially what we're saying is that there's things out there, data, records, some sort of IP, and when you string those things together, that entire connection of those things become our product definition. So let's dig into that a little bit and just look at what sort of things we might string together as we start to build that digital thread. And when you look up on the screen, you see a lot of different elements, and it's not to suggest that every industry or every company has each of these elements, but the point is that there are lots of different things that need to come together to build that digital thread. The other point is that that digital thread goes through the life cycle of a product, that life cycle starting way over on the left when requirements and definition is happening, all the way through the middle where we're actually doing design and development of the product, and then even beyond its manufacturing into physical instance tracking, potentially service and MRO and those sort of things. Again, you won't necessarily have each of these components, but the point is that these components work together to build that digital thread. You may have components that we don't show here, but the point is still the same. We build those things together, we connect those, and those make the digital thread for us. So as we talked about on our last webinar, why would someone want a digital thread? What is the value and the benefits that it brings? Well, let's talk just about 3 of those for starters. The first one we'll talk about is what we'll call decision support. And you notice our little quote down there that you've probably heard from Joe Employee before, where he says, "If I had only known." Imagine the scenario where you've got an engineer who either is new to the company or maybe new to the product line, and he's asked a question about that product line. The VP of engineering wants to know, what should we do with this? Maybe it's time to redesign it. Maybe it's time to get rid of the product altogether and replace it with something else. Now, this product's been around for years, and it's hard for that engineer to make comments and to have an opinion without knowing the history of that product. So You think about the market studies that were maybe done at one point. You think about maybe some work that was done in the test lab to determine the fidelity of the product and its reliability. All of that data went into the design and development of the product. And here we are at a crossroads to make a decision about this product, but can we find that data? Do we know why a hole is a particular size versus another size? Why one material was selected versus another material? Somebody did the research at some point. If we had that all connected, we have parts of that digital thread that help that decision support. Another thing that can help, the digital thread can help with, is automation. And so automation has become something that's ever increasing in companies, particularly as we think of the horsepower that exists when you get into things like cloud computing and some of the CAD stations that, decades ago you had to have a dedicated machine to do analysis and FEA and fluid dynamics and those sort of things. Well, now we have that opportunity at many people's fingertips. And if you think about some of the AI and the tools that exist that allow for things like continuous optimization. So there's programs out there that can run an analysis against our CAD designs. Based on the results of that analysis, they can make some decisions, do some mechanical optimization, and rerun the analysis and continue to do that. The key is, though, those programs would need access to not only our CAD design, but also some of the requirements. So how do they know what to optimize? How do they know what they're shooting for? Well, again, the digital thread allows us to tie that information together so that we can support these sort of activities in these sort of tools. The last one we'll talk about is something that we'll call forensic. And that's where we want to dig deeper into our product or potentially a problem with our product and really find out root cause or impact analysis. So imagine the scenario that we have a product and we've built a number of these. There's several of these things out there in the field, and there's a failure. There's a failure of just one. One of the instances of our product has a failure. And after we dig into it, we find out that the reason the part failed, maybe it was something related to the manufacturing of that part. There was a machine that was out of calibration or out of tolerance that day that that part was manufactured. Wouldn't it be nice to know, of the other products that are out there in the field, which ones have that same component manufactured on that same machine on that same shift when it was out of tolerance? You see, if I knew that, I could go out and proactively find those products and get them fixed before there was a failure. But the only way to do that is to know more than just the physical design components, just the CAD design. I need to know things about manufacturing. I need to know things about operations that were performed. I need to know things about timing on when those operations were performed. And all of that stuff comes together to build that digital thread and allows me to do these sort of forensics that we're talking about. So that's why individuals would want to have a digital thread. There's other reasons as well, but those are a couple that come to mind and that are pretty easy for everyone to understand. So let's talk about what we're going to get into in the webinar today. Today, we're going to get into how we can get started. We're going to pick 3 ways, and we're going to talk about those 3 ways that we can get started in building that digital thread. We're going to do this in a little bit of an interesting way. Instead of just throwing up 3 different ways and talking about those 3 ways and how you might do them, we're going to introduce you to those 3 foundational components that are required to have a good digital thread. And then we're going to show you those components in action through some case studies. So Jonathan's going to take us through case studies where we'll get to hear from Razorleaf customers, or we'll get to hear about Razorleaf customers that have done these, that have built a digital thread, and how each of these ways mattered to them and what they did to accomplish that. So the first one is assess. That's the first step that an individual would need to take. And a company would need to know their current situation. So, how do you close the gaps if you don't know what the gaps are? So what are our strengths and weaknesses? So a company is going to look at their current situation. What do we have today that maybe is already making up part of that digital thread? What's missing, and what do we need? And so that's going to happen during assessment. Try to set some priority. So it may be that a full fidelity, fully connected digital thread isn't necessary for the products that you make. Maybe you need a subset of that. Again, understand what the priority of those things are, so we can begin to determine how to build that digital thread. What's our processes look like today, and do we just want to track current processes, or are there opportunities to improve our processes? So not only is our digital thread tracking them, but our digital thread is also efficient. And so those are some things that would happen under assess. During educate, a company needs to know what their options are. So options can sometimes revolve around technology. Are there tools out there that can fix this problem, or that can make this easier for me? Maybe it's a process issue. Maybe it's that our process is a little bit old-fashioned and we've just always done it that way, and it's time to update it. Maybe a little bit of both. But we need to know something about what our options are. We need to know what tools are out there. We need to know what our tolerance for change and for update is. So that happens during the educate phase. And then lastly is the roadmap phase. And so during the roadmap, we want to take a long-term view of what our digital thread is, what our digital thread goals are, and then also take a short-term view of what we can do quickly. So what are our priorities? What needs to happen today, and what do we want to get out of the digital thread today? But don't forget our long-term vision, because we don't want to paint ourselves in a corner. Maybe there's some things that we would call low-hanging fruit, things that can quickly be accomplished to go towards that digital thread, that will get some good visibility, will get us some good wins, and good efficiencies, and it doesn't take a lot of work to do it. So let's identify those during the road mapping session. What kind of team do we need? Is this all internal people that can do this? Do we need to bring some consultants or outsiders in? Are there tools that we have to buy, that we have to bring people in to help us with those tools? And lastly, let's understand the ROI. Companies don't spend money on solutions unless that solution is going to save them money or make them money. So let's understand how that's going to happen, so that we can A, justify our work, but more importantly, make sure that any of the work that we put into this, that we actually meet our goals, that we know what we are trying to accomplish and we can meet our goals. So that's kind of a summary of kind of the three foundational areas that we believe need to happen as you undertake this digital thread. Now, I'm going to turn this over to Jonathan. He's going to do two things for us. First, he's going to continue just a little bit of this refresher about the digital thread. Then he's going to jump into these three case studies we talked about. So go ahead and take it away, Jonathan.
Thanks, Derek. Appreciate it. And hello to everyone out there. So like Derek said, I want to continue that refresher just for a second. In our last webinar, one of the things we talked about is how PLM can support the digital thread. And there's a very useful concept from that I want to share as part of each of these case studies today. So I just want to refresh everybody on that. What you see on the screen is a diagram of a PLM system, basically. So you see kind of the life cycle of a product: concept, design, manufacture, service on the outside. And each of the green pieces of text really reflects sort of an area or a module of the typical PLM system. So this kind of diagram of PLM, we looked at it and we put it in the context of a digital thread, like you see at the top of the screen, and just took a look at how that digital thread can weave itself across some of these modules or areas of a typical PLM. So I bring that up because as we go through the case studies that I'm about to talk about, I want to close off each one with giving you kind of a picture of what that organization's digital thread looked like. And we're going to pepper in some other systems on this diagram too, because not everybody needs PLM exactly, and it's not always neat, and it's definitely not always the same way. But just wanted to use this frame of reference with each of the case studies to give you a picture of kind of what did their digital thread look like. Okay, so enough on the refresher. Let's jump into the first case study. And like Derek mentioned, I want to use each of these to talk a bit about that assess, educate, roadmap framework, about the ways you can get started. And like I said, each company, each organization is unique in their digital thread. Each one of these case studies was also unique in terms of what was important to them about how they got started. So I'll start with this first organization. This is a defense client. So without getting into exactly where they fit in that defense ecosystem, I'll note that they're at the top of the food chain in that ecosystem. They own a high value asset with a very long life. The lifespan of this product is, I want to say 30 years minimum, 50 years maximum, potentially longer. But what's really important to note about it that feeds into why they cared about the things they cared about is that the full life cycle cost of that product is much greater than the purchase cost of that product. So this particular example is about $200 million to buy one of these things, but over its life, it's in the billions of dollars to maintain just one of them. Okay, so things that contribute to that are maintenance and buying spares and upgrading that product, and another one is data leakage. They're concerned about over time, what if I lose the data about it? How can I upgrade it if I don't have the technical information, that sort of thing. So that's just sort of generally the kind of organization we're talking about and what they're challenged with. But specifically, let's dig into what was their challenge. How would they describe it? And they would point it out with a very specific need. Can you buy me a spare whatever, right? So pick a module or something on this product that they have that will safely fly or sail or ride on my weapons platform. Can you buy me a spare? And can you do it today? And do you have what you need to do it 20 years from now? Because that's just as important. I mentioned that long life cycle cost, and sometimes those parts get more and more expensive as time moves on. So that was their challenge. How did they solve it? Well, before I talk about how they solved it, let's talk about how they got started. So this case study, I want to highlight the assess part, because that was their biggest challenge. In their world, there are already IT systems out there that did the kind of thing that we're talking about to solve their challenge. But those IT systems, the ones that they could have just picked up and used, actually didn't solve the problem. Things were changing in their environment. They were getting 3D solid models of data, and they saw that the world was changing, and it was a different situation than the tools that they already had. So as part of their assess, they understood, oh, wait, I need something that can manage CAD data. I need something that can manage 3D CAD data and model-based data and connect that with bills of material. And I need to get it from different suppliers and. I won't get into all the details. We're going to touch on those in a minute. But when they did that assessment, they instantly realized, okay, we need something. We need something beyond what we have today. The education part was quick for them. The roadmap part was quick. But assess really opened their eyes, and they had to do a lot of have a lot of conversations internally to make sure everyone saw the problem the same way. So assess is a really important step. So what was their solution? I'm going to detail it and just take you through some of the things and key parts of it, but it was a digital configuration management tool based on PLM. So they needed PLM, but really they refer to it as a digital CM tool. The way they would describe it is, I need a detailed bill of material for each physical product that I have, each one of those $200 million assets, that lets me point to the drawings and specs for each component. That's what they needed to solve the challenge on the left. So let me just take you through quickly, what did that look like for them? So it's almost as much about a process of building their digital thread as it was looking at what that thread was at the end of the day. So a couple of steps that are important for them. First, they had to receive the bill of material, the CAD data, the document data, all of that from the OEM or the system integrator, right? So they're purchasing, I say that loosely because they were very involved in the development of this asset, but they were purchasing this asset from somebody who brought together a lot of different suppliers and designers, and as a large team, they designed this thing. But the first step is they had to get that overview of the technical data from the OEM. Then they have to get the rest of the data, because that OEM, that systems integrator, certainly had enough data and knew enough to pull everything together and make sure that the product would work. But they actually didn't have all of the data. Some of that stuff was proprietary to the supplier. So again, this organization had to collect data from different sources in different formats. You notice that here in the purple and the green. It's not all homogeneous data. Some of it's very different. On top of that, they started doing this at the beginning of the development of the product. As the product continued to be developed, and as the first couple of versions of this product, or the first couple of physical instances were delivered, changes happened. Things didn't work out in manufacturing. We had to upgrade this, or it didn't perform right, and we had to do that. So engineering change became part of something they needed to receive and get updates to data. And you can kind of see that with the orange here. They needed to catalog the engineering changes and understand what the impact was to the bill of material. And they needed to get all the new records, new CAD models, new CAD drawings, new documents, and how all of that related. Keeping in mind, they didn't do this design work themselves. It was coming from lots of different people. So they also needed, if they were really going to have a picture of any specific instance of the product they owned, what actually was on it and was not on it, each time there was a new delivery, each time they had one roll off the factory, off the assembly line and was handed to them, they needed to know exactly what was on that one. So sometimes you see this kind of the red gears on the left is a specific instance that they received. It might refer to old data that you see in gray on the right. It might refer to current data, but they needed to know that. They needed to track it. And furthermore, once they sort of owned the product and they had it in-house and it was, flying around or sailing around and they had to maintain it, they also needed to keep track of that new data that had a life of its own where they owned it. So you see this in the yellow, right? They might take a component that got, dinged up on deck of a ship or, might have run over something and damaged the product. They needed to fix it, repair it, and they need to redline the drawings for what that was, again, so that they'd know that specific one had that damage, had that repair. So all of this is the sort of stuff they had to keep track of and then maintain it as service bulletins were applied, right? So as changes to their fleet came out, because we've got an upgrade, they need to incorporate that and update the bills of material for the as maintained bills as they went. Now, I'm going to add in one last step here, another function that was really important to that original challenge of, can I buy a spare thingamajig for now, for 20 years in the future? They need to take all that data we just talked about, that configuration management of the digital products, and be able to package it, be able to share it, right? So in their case, it was making PDFs of this technical data, but specific configurations of that technical data. So these are all the kinds of things that they needed to do and what they needed their digital thread to support. So like I said, they assessed early on what they were missing when they looked at, well, here's what we need to accomplish to solve that challenge. And that's what pointed them in the direction of, this is the kind of thread we need to build, and these are the kinds of tools underneath the hood that we need to put in place. So this is what their context looked like. One of the things I didn't mention that was very important, and I wanted to use this slide to highlight it. If you see my cursor here, this MRO, maintenance, repair, and overhaul. They actually didn't have a single system to do that. They had a collection of point solutions out in the field that when things were repaired or maintained, they would record, well, this serial number came off of it and this serial number went on to it, that sort of thing. So they had to tie this digital thread that they built on a PLM platform together with these legacy point solutions so they really could keep track of their as maintained physical instances. But hopefully you see the idea here. They had a pretty complex and robust digital thread. And what was important to them at the outset was that they assessed what they needed that was different from the tools they had available to them today. That's what helped them build this. So that's a good first step to consider. Okay, let me move on to our next case study. This next organization operates in the transportation industry. So specifically, they make kind of a small widget. It's a high volume, low cost component. It's actually a little plastic piece that goes into lots and lots of cars. They operate in a supply chain / design chain scenario. So their customer will come to them and say, this is what I think it needs to do. And they will go back to that customer and say, yes, but it should look like this. We can make it out of that. It needs to be a little bit different than what you had in mind. We're the experts, trust us. Here's what it should look like. So that's the kind of world they lived in terms of design and manufacturing. Also, it was automotive, like I mentioned. So any of you who are familiar with this industry may know they've got very specific constraints on their operating environment. Customer X uses CAD tool version Y, service pack Z, hotfix, whatever, and they need to exchange data with them in that way. So there's very specific requirements around that. The other part that was interesting about their business is they had a very scalable manufacturing capacity because they're making these small plastic parts, they can just add warehouse space and injection molding machines and get their tooling, and they can really build out capacity very quickly. So it was a balance for them between the engineering and design capacity needed to capture business and that manufacturing capacity needed to actually execute and deliver, but they needed to keep both sides of their business balanced. That's how they worked and how they made money. So their challenge was, can you steadily grow market share? In other words, can we get new auto OEMs coming to us? Can we win more of the business from those auto OEMs while balancing that engineering manufacturing balance, right? While keeping that all the way it needs to be, keeping everyone busy. So this case study, I want to highlight, they needed to get started with the educate piece, because the assess part they already had figured out. They had tons and tons of point solutions around their business related to the various things they needed to do to keep that balance going for their business. So they already understood what they needed, but they didn't understand what was out there on the market, what the possibilities were, and how it could change the way they looked at the technology they had, the way they leveraged it. So they needed education. Well, what did they come up with? With that problem they were trying to solve, really, it was sort of a management issue, right? That balance question was a management issue. They needed real-time visibility across the hundreds of projects that they had, with insights into all these little variables about those projects. They traditionally had done it with a spreadsheet. Like I said, they had very good tools. They understood the strengths and weaknesses of their process very well. They didn't need to assess. What they needed to know was, is there something better out there to help us bring it all together, to get insight out of it? And that insight was dependent on the collection of all of this information, putting it all in one place. So let me just take you through a little bit of that, how it all looked and came together for them. So the way they solved their problem, all these point solutions they had CAD data, technical data coming in from their OEMs and feeding into kind of a standard project plan, right? So they had standardized project management. We always do these steps, and that's how we get to the end. We might cut a project off if we lose the job or if we decide not to quote it or something, but generally we always go through these steps. Okay, so they always go through that typical timeline, and the CAD data is fed in. Early on in the process, they need to calculate cost. So they do some early bill of material work, and they determine what the cost would be to the product that they're proposing. They need to feed data back, right? So if they're giving design input back to their OEM, they need to share, well, what if we did this? What if we did that? So that's another key part of their project. They also need to project what's the volume going to look like. Are we going to sell how many thousands of these per month? And is it going to last for a year, 2 years? How many model years will it apply to? That kind of thing. They also need to know, what do they think that the OEM would pay for the part? They might have a cost target that the OEM gave them. They might think that they can play with that a little or manipulate it. So they need to have an idea from sales. What does the price target look like? And they also need to start preparing towards the end of their project the quality deliverables back, right? So I mentioned it's an automotive environment. APQP was very important. So they had deliverables and milestones they needed to hit back with their customer or potential customer. And of course, the other thing they need to know is, well, how far along are we? Which of these things are done? When do they need to be done? When is our quote due? Those kinds of things. So they need to understand the timing of all this. That in and of itself probably doesn't sound terribly tricky. And honestly, per any one project of theirs, it wasn't. What made it challenging is that they had several hundred projects per year with more than 100 going on in parallel at any one time for a pool of people. And like I said, they needed to balance the manufacturing capacity and the engineering capacity and try to keep everyone busy, because that was the key to being profitable. Okay, so if this is what they needed to do, what did the digital thread solution look like for them? Well, at the end of the day, it looked like a dashboard, right? Now I'm going to talk about how this mapped and what supported it here in a second, but it was really pulling all of that information together and reporting it in one place so that you could make decisions, to bubble up that insight up to a management level, to give the managers the tools, the levers they needed to be able to make decisions, speed things up, slow things down. I'm just going to highlight one thing on here for you, right? this is obviously a mock-up. I can't show you their exact, what they did here, but you see this project. This project looks really promising. It's a tremendous volume for several years. It's due soon. We think the price looks really good. You see, that's higher than just about any other price we sell our components for, but we don't know the cost yet, right? So that's the comment. The strength of their digital thread solution, what they were happy to find when they educated themselves, was that they could put something in place that would let them go from this view, which they already had in a spreadsheet, they were already doing this, down to the actual view of, well, is there a bill of material? How many components are defined in that bill of material? Are costs assigned to each of those components? How close are we to knowing the cost of that bill of material? They could actually drill through this dashboard because the data was live. It was all connected through a digital thread, and they could get to information they needed to make decisions. That's what was so important to them, is not just a nice picture of things, but that they could drill to the data. That's why the digital thread was so important. What did that look like for them? This was it. This is a relatively simple looking digital thread compared with the first case we looked at, right? So project management was at the center for them. They needed to have those predictable project schedules planned out and connected to the key deliverables, the CAD, the BOM, the product content, all those things. And the manufacturing definition, the APQP data, all those were sort of standard work that they needed, but they had to have it all tied together with the project to get that dashboard. They also needed to tie it to their data exchange framework because of the industry they were in. So they can't spend time with duplicate data, losing data, not sending people the right version of data. So this was equally important. But that's what their digital thread context needed to look like. So again, out of our 3 case studies here, the second one, for them, it was really important to educate themselves on the fact that there were tools out there that were project-centric, but yet could tie to engineering and product content, and the status of their projects could be driven based on the maturity of these other deliverables. That was an eye-opener for them. So once they had educated themselves on the fact that that was possible, the rest was easy. For them, the road mapping step was straightforward. They knew what they needed to do in what order, and that's how they got to their solution and built a digital thread that looks like this. Okay, let me move on to our third case. So our last case study, this one really highlights the need to roadmap, to make a plan for what you're going to do. So this customer, I'm going to call them an energy client. That's really the industry they operated in. You might feel like this is relevant to anybody making some kind of equipment. So it is sort of broadly applicable. They worked in the energy industry, and they were a component supplier. They made a safety critical regulated component. They actually had a portfolio of components they made, but I'm going to speak about one in particular that was really interesting for them. Their niche, how they were growing in the market, is they were remanufacturing used parts. So they would buy something that had had a life of 3, 5, 10 years. They would remanufacture it and resell it out on the market, recertify it as well, because like I said, it was a regulated component. So what was their challenge, right? They had a very specific problem they were facing, which is they would make mistakes. Like I said, they were niche, they were a startup, they were growing fast, it was exciting. Really, they were putting lots of businesses together and making acquisitions, that sort of thing. But what would cost them profit margin is a mistake. So I'll tell you more about their product in a second, but they were making mistakes on the shop floor, and they wanted to know, can we prevent those mistakes by putting the right data in the right place at the right time? They had a second question too, which is, and if we do that, can we automate some of the pedigree of our product? Because they did spend a lot of time also running down the certifications of the products that they made. Did we actually make it the way we said we made it? What did we really ship to the customer? Was it serial number 1 or serial number 5? So they wanted to know, if we automate the first piece, can we also automate the output, the pedigree on the backside? So I mentioned the roadmap was most important to them. Their solution, I'm highlighting it here in the form of steps, because they had already assessed what they needed. They knew that they needed a way to deliver data directly to the shop floor with no ambiguity. They knew they needed to control their data. They had all that figured out. They'd already educated themselves, and they'd already actually started on their digital thread journey. they had a PDM system in place. So they had figured out the assess piece, they had figured out the educate piece. They needed to know, well, what do we do with it now? How do we get to solving this challenge with the things that we have? And the solution ended up being extending the PDM to put manufacturing data in it, automating data delivery by actually working with a couple of other systems they had, and then putting rule checks in place, because that was the last key part about preventing the mistakes. So that's what they did. Let's take a look at how that looked. All right, so first, what was their product? I want to give you a little more backstory on this because I think it really drives the point home of why this was so important. They were making or remanufacturing a large block of steel. That's why the mistakes were so costly. This thing is about the size of a Volkswagen Beetle. So, you make a mistake and you scrap a part, you've got it's a costly mistake. You really eat into your margins. So it was also a used component. I mentioned this, they're remanufacturing. This thing has a service life of several years. So when they get it in, it's pretty beat up. It had oversized holes, it had worn out features and finishes, things that needed to be repaired. So the remanufacturing that they needed to do, they needed to do inspections. They needed to do welding to build material back up with specific metals, special metals. They needed to machine back to the good state. They needed to then add some of their own features to make the design unique to them. So there were a lot of manufacturing steps that were important and pretty specific. That hopefully gives you that background of why this was so important. So what data did they have? Okay, just to give you a kind of a detailed picture, the engineering perspective on what they needed to do is they would define the final product, right? They make a drawing and a CAD model of the final machine product, but all these steps that they had to go through, they had to make sure they got them right. So they would create a bill of material, or really a bill of process, showing the rough machined model and drawing, showing the built up model and drawing, and they would have to change these based on what they were getting in as used materials. But they would need to build that up, but then they also had to do the machine programs, right? The CAM programs to program their CNCs for this. So for every CAD model and step in their process, they would have a CAM program or two. Each CAM program would have one or more CNC programs because, again, I mentioned this was so big, that's why I gave you this detail. They would have to go through an operation just to turn the thing. So they'd have to have a different program for the top than they would for the sides, because it might be machining for 2 or 3 days. So anyway, you get the idea that this built up to quite a bit of data, right? So from the engineering or the product planning perspective, we had multiple CAD models, multiple CAM programs, and even more CNC programs just for one part of this thing. Okay, well, how did this look from the manufacturing side? So when they actually planned to run it through the shop floor, it was a little different view. Okay, so they would have a part, but they break it down into operations and sequences. So operation 1 is inspect it, operation 2 is build it up, operation 3 is machine it. There could be other operations in the process. But within one of those operations, there were sequence steps, right? First, I've got to do the top build up, then the bottom build up, then the front build up, then the back build up. Each of these might require a crane lift to get the part turned around. So you can see they needed to use exactly the right CNC program. That's what you see over here on the right, for the correct sequence and operation as they're moving it through their shop, right? So this goes on and on and on. It could be very, very complex list of operations and sequences to get a part made. Another thing I'll highlight here is, notice it didn't all happen directly in order. That's why there were mistakes. So that's the problem they were having, is machine operators who would load the wrong program at the wrong time, or they'd have something that's out of date, and that's how they'd make mistakes, cut bad metal, and they'd have to go back to step 1, inspect, and build up again, and that was costing them money. So what did it look like when they started, right? When they realized the challenge that they had, it looked like this, right? So here at the end of the process is the work center where the operator would run the CNC machine, okay? But the designer would create 3D models and CAD drawings. The MRP, or manufacturing planner, would do the plan, the op sequence plan, over in the MRP system. The CAM programmer would create the CNC programs. And then how did it get there? Well, it would get to the operator because that manufacturing planner would collect up a bunch of drawings, put them together with a traveler of all the operations and sequences, put a package together, and then get that package to the operator. once the material arrived and that package goes to the operator, the CNC programmer, then it was his responsibility to go get the right CNC program. And so that they weren't going back and forth, they would just get all of them, right? So give me all the CNC programs and I'll sort it out with the traveler when it's time to cut parts. And then it was up to that operator to pick the right program at the right time to cut the part. This is where the mistakes happened. And oh, by the way, you had to hope throughout this process that nothing changed, right? That there wasn't an engineering change in the process and the model and the drawing didn't change, because of course that would change the CNC data too. So several things contributed to problems. That's what led them to a final solution that looked like this. So same sort of early process. CAD designer would make the CAD data, put it in the PDM system, but they realized we really should connect that to the manufacturing data, so that CAM program and the CNC programs then got stored in the PDM. That CAM programmer would actually pull the data out of PDM and put the manufacturing data back in. The MRP step still happened the same way. They would create the BOM, the operations, the sequences, but when the material arrived and we needed to start actually cutting metal, this is where things were pretty different. So now the manufacturing planner would take that traveler with the BOM, the op-seq steps, to the operator, and then magic. So it now had barcodes on it. The operator would scan the barcodes and magic would happen. So the program would look to PDM, it would understand the right versions of things. PDM would talk to MRP, read the specific parts, operation sequences, that sort of thing, and then go pull the right data out of the PDM system for that. It would then perform rule checks, right? It would make sure that the drawing wasn't undergoing a change. The CAM program wasn't undergoing a change. The CNC program from the CAM program was the latest available. That magic then would continue because the PDM system would then push the right CNC program to this DNC tool, right? It's another piece that they knew they needed. They added into their architecture so that the CNC file could go straight from PDM to DNC to the CNC machine itself. This way, the operator didn't have to load anything onto the CNC. There was no opportunity for mistake. At the same time that CNC program was going to the machine, the drawing was going to the operator's screen. Again, the operator didn't have to go find things or locate information. It just appeared. All he had to do was press the button to start the machine to record the fact that the work was happening. And oh, by the way, this dealt with that pedigree issue too, right? The systems were all recording exactly what version, on what date, at what time was used to cut metal. So you see how it was important for them to figure out in their roadmap when to add the DNC piece, when to connect this CAM data into their PDM system. That's what their roadmap was about. That's why it was important. They didn't do all this at once. They did it a step at a time, connecting this into PDM, adding this to their architecture, connecting all their CNC machines to it, then writing the automations here, writing the automations here. So that roadmap step, thinking through what they wanted, the benefits they needed to get, that's what got them to the result they needed. So just to take a quick look, what did their digital thread look like? Again, slightly different than everybody else's. Some basic PDM functions really, right? Because this was all happening in a PDM system, not even a full-blown PLM, managing CAD data and change data and keeping track of it together through CM. They added the manufacturing data in and then just connected it to these other business systems to keep this full digital thread winding through all those components. So that gives you a picture of sort of a third case study, somebody for whom road mapping was really important. Let me just, let me drop there. Go ahead, Derek.
Jonathan, that was fantastic. Thank you for going through those with us. I want to take just a few minutes and kind of tie back some of the things that you shared with us back to our three items, 3 ways to get started there at the beginning. And
yeah,
so
absolutely.
you'll remember we talked about assess, educate, roadmap. I'd encourage everyone that's listening just to think for a second about those 3 scenarios that Jonathan laid out and imagine the solution if those customers hadn't done assess, educate, and roadmap. Could you have ever got to where they got to without doing those things? I think most would agree that that would be a big ask to get there without understanding these things. But meanwhile, each of them kind of did it in a different order. Some of them had already done some of these steps, and some of them needed to do these steps. So when we think about that assess step that's necessary, we go back to our defense client. They had to think about things like what's needed 20 years from now. That's not something that comes to the forefront of your mind necessarily when you think about a digital thread, but they had to think about that. They had to really assess what their current IT landscape was like. They had tools that were doing some things, but could they handle 3D and solid models or not? And could those tools connect with the OEMs and the suppliers? And so they really had to assess what that looked like. They really had to assess where their digital thread comes from, because we've got the suppliers, we've got the OEMs, we've got others involved. And so where does all that come from? And so you really could never have gotten to a digital thread solution without going through those steps. When we think about that educate step, and we think about our client in the transportation industry, as we mentioned, they already had much of this figured out. They knew their process pretty well, and they knew how it operated, but they didn't know what options they had. They didn't really know what was out there. Are there out of the box, off the shelf sort of solutions, or is this something we're going to have to customize? Is there something better than what we have? And so they really had to educate themselves on two things. One, what are the options that are out there? But they also had to educate themselves a little bit on what exactly do we need. You think of that slide that Jonathan put up where the executives have a dashboard and they make some decisions. So we had to educate ourselves a little bit on what decisions are we going to need to make, and what data is needed to feed those decisions. Hence, what does our dashboard need to look like? So again, I asked the question, could they have ever got to a digital thread had they not went through that educate step? And then lastly, the energy client that we just talked about, who went through the road mapping process, again, a pretty mature process that they had in place. So many of these early steps were already done, but they really had to think about what it is that we want to get to. And they wanted to get to some better automated and higher quality manufacturing, and then potentially even that automated certification, or at least certification that was more automated than what they had today. And so they had to look at what they had today. What do we have? We know we've got certain tools. Do we need any new tools? They realized they needed a DNC tool. Are there things that we have to put in place, like a rule check at somewhere along the line? And so they thought about those things. And as Jonathan mentioned kind of towards the close, this didn't happen all at once. This is something that they did step by step. They found some low-hanging fruit. Remember, Jonathan mentioned about the barcoding of the traveler. Instead of a paper traveler, there's barcoding, which when scanning it pulls up some information automatically and sends drawings to operator screens. That's a fairly easy thing to do in order to get a lot of benefit. And so they were able to do that. So again, the point is, here is what we're recommending as the 3 steps that you really need to go through to get to that digital thread. And everybody on the webinar is going to be at various states of maturity when it comes to these 3 steps. But certainly, you need to go through these steps. I might just touch lastly before we get to some questions on how Razorleaf might be able to help with some of this as well. One of the things that's unique about an outsider coming into a company is they do a couple things. One, oftentimes they look at stuff from a little bit different perspective. They don't live your processes day in and day out, and sometimes that's good. Sometimes it's good to have someone come in and assess you that isn't kind of beat down by some of the processes or frustrated with some of the inefficiencies. The other thing that we can help with is that we've seen many of these challenges across lots of clients. So while the challenge is certainly unique to you, the probably underlying reasons for the challenge are something that probably exists in a lot of places. And we've seen these things, and we've seen how people have addressed them, what has worked and what has not worked. When you think about educate, one way Razorleaf can help when it comes to educate is there's a lot of resources out there. You could watch YouTube videos forever about digital threads. Which ones are important to you? Do you go out and spend months watching videos and reading articles to find the data that you need? Or would it be better to have someone point you to something that's a little more directed towards what you're looking for? And so again, that's an area where Razorleaf could help. And then when it comes to road mapping, our experience in rolling out these technologies should be able to help you to determine what can we do early? What's the expected ROI on this sort of stuff? What should we do later? What sort of things are interconnected? if you're going to do option B, you have to make sure you do option A. You don't want to do option A later. It's going to be a lot more expensive if you don't do it now. Someone who's been through this process can help you build that roadmap and help make sure you have a roadmap that's executable. And so those are areas that hopefully you learned a little bit about today. And then, like I said, if there's something that we can help you with, we'd love to give you a hand with that. Kristen, I think we have a few minutes. If there's any questions, Jonathan and I would love to entertain a few questions.
Yes, thank you, Derek and Jonathan. That was very informative. We will begin our Q&A session. And just a reminder, any questions, please enter in your question panel below. We do have one here. All the examples sound like a lot of work. Is it worth the time and expense?
That's a good question. Jonathan, you want to take that, or you want me to take a crack at it?
Yeah, go for it, Derek. Yeah, I think you probably got a good perspective on that.
Yeah, so is it worth the time or expense? I mean, I think the first thing you have to remember is that the digital thread is not the same thing for everybody. So our defense client, the digital thread that they built, that probably goes down to the nut in the washer on that physical asset, is not necessarily the digital thread that a company that makes toasters needs. But that doesn't mean that the company that makes toasters doesn't need a digital thread. It's just a digital thread that maybe looks at stuff at a little bit higher level, or not quite as much detail. So I would guess my answer to that question would be don't get caught up in the detail and automatically assume high cost because of the high level of detail. Keep in mind that every company and every industry is going to look at the digital thread a little differently. And so is it valuable? Well, think of some of the things we talked about early on about what the point of the digital thread is: to help us with decisions, to help us with automation, to help us with forensics. I think even companies that make toasters would agree having better decision support, having automation, and knowing how our product is performing in the field would be a good idea. And that's really only possible through the digital thread.
Yeah, Derek, I'm going to chime in too. I would echo that when people are concerned about something being too complex to be worth it, that really is the first question about assess. And maybe the third suggestion we had about road mapping too, and thinking about the ROI, that energy client, that was really important to them because they were a small startup. They didn't have a ton of budget, and they said, this seems complicated. But what they found was a very directed solution to a very real problem they had, and it had very real dollar consequences. And that's what got them to build that digital thread. So I think you're right. It's different for everybody, but it has to have practical application. And if it does, then it shouldn't be too complicated to solve.
Yep, agreed. What else we got, Kristen?
Great, thank you, Jonathan and Derek. The second one is, what is the best way to educate myself about all this information if I've assessed my situation and think I know what I need?
Yeah, Derek,
so let me
go ahead,
Jonathan. Well, I was going to say that there's a lot of resources. The one thing I will caution, I'm going to turn over to you, Jonathan, is that as you're assessing, be careful with looking at just trade industry information. So when I say that, what I mean is like, just the standard IT white paper on how to implement a business system. There's probably some value in those sort of papers, but keep in mind that there are things that are unique to the systems that we're talking about, the PLM and the product-based systems, that some of those more generic papers and education resources don't go to. So I would encourage you to look at those things, but understand that really trying to find resources that are specific to product design, and product lifecycle, that's really where the best education is going to come through.
I agree with that, Derek. And I think what I was going to add is you also have to be careful about the bias of the information that you read. I mean, we all know that on the internet today, you can find lots of information for free, but you have to think about why is it out there? Why did somebody take the time to provide that information? And 95% of the information you find is going to be about somebody trying to sell you something. A lot of times it's a software product for the area we're talking about. Like you said, you need to find the ones that are really relevant to what you need, because trying to use SharePoint to manage product data probably isn't great. But if you read a SharePoint white paper, it might make you think so. But you also need to realize, whatever it is that somebody's trying to sell you, they've got a specific way of looking at the problem, a specific way they solve the problem and frame the problem, and that might not be what your situation is. So consider the source carefully. I'll put in a plug for us here a little bit. You know, we work with multiple different PDM and PLM products and other engineering technologies. So we work with a lot of different tools, and we do a lot of work that's just process-based. It doesn't have anything to do with software. So having multiple perspectives and experience is really helpful when you're trying to educate yourself. So even if you're not talking to somebody like us or working with somebody like us, you know, just try and get broad perspectives and consider the bias of the source when you're gathering information.
Very good. Well, Kristen, I think we've about run out of time. So if anybody else entered a question in the question panel, rest assured we will answer that question to you directly through email. So any questions that were asked, we will get you an answer out to those questions. Before we conclude, I just want to talk about where we go from here. So there's a couple things we'd like you to think about. One is something we mentioned last time we were together, which is on Razorleaf's website, we've got a digital thread assessment little report we'd like you to take. Kind of walks you through some of the things we've been talking about in the last two webinars. You get to kind of do a self-assessment about how good I do this or how bad I do this. And then based on that information, you can do a little bit of scoring about where you are in your digital thread journey. Along with that, if you fill out that information, we would love to spend 30 minutes on the phone with you with one of our consultants, kind of analyzing that information and talking with you about our perspective of what the best next step is. And then lastly, I would say that we've got another webinar coming up November 5th. This one's kind of exciting. We're going to do some live group road mapping. So the participants that come, we're going to ask you to ask us some questions and tell us a little bit about where you are in your digital thread journey, how far along you are, what challenges you're having. And then Jonathan and myself will kind of analyze that. We'll give you some feedback on what we think is the right step to go to and how you get past maybe some of those hurdles or accomplish some of the goals that you have. So if you've got specific interest or questions, you know, please join us and share those with us. You're welcome to share them with us in advance of the webinar as well, and we can answer them to you directly and at the webinar. Maybe you don't have specific questions, but you want to hear what other people are doing. So again, join us, and you'll get to hear how other people are facing the challenge of building the digital thread and hear what our comments are on how they'll get there. So with that, I'm going to thank Kristen for emceeing for us today. Jonathan, thank you very much for your expertise and your experience in these case studies. We appreciate everybody joining us, and so have a good rest of the day. Again, everybody will get a copy of this recording that you can watch again or share with your colleagues. So thank you very much.